Hi guys, my project is Clean Air Analytics and comparison of big data technologies. So for Clean Air Analytics, I'm doing a lot of analytics uh, based on PM25 concentration. Uh, at the end, what we want to show is the traditional system right now we are using for analytics not enough because of constraint of computational power, and we want to move to big data technologies. So this is my website or web application. It includes different tabs like trails, heat map, live stream, analytics. Analytics includes other four analytics type, four analytics and correlation, and then pedestrian. So this is our landing page, starting page, which is trails. It includes the trails or uh, the data collected by different citizen scientists around Melbourne. So these are the data uh, uh, in their journey. For example, Arjun has connected 55.276, and there are other citizen scientists also which are collecting all this data. So we have just plotted this data. In live stream, what we did, so in live stream what we are doing, instead of plotting the data stream or data collected by all the citizen scientists, we are basically plotting for a particular person on a map, but this we are doing in real time. And as it's very difficult to plot for all the scientists because of computational constraint for traditional system, we just did it for a particular person. So what here it's doing is, so as soon as in real time aircasting app sends data to Ruby server sends it to MySQL in real time, and as soon as the data is present in MySQL, we are making a query every 20 seconds to get the new data for a particular person on this map. So it will be plotted, all this data will be plotted in on this map in real time, and you can see how what data is being added and how is it adding. Now from trail and live stream to heat map. So in heat map, we are showing PM25 concentration in different region in order to know in what region the PM25 concentration has been increased up to an unhealthy level. So basically this red spot you see, it's very unhealthy. So this is the CBD area, it's near University of Melbourne Park campus, and this dark brown region, this is unhealthy. It's less than red, but it's still unhealthy. However, light brown region, this is a very low PM20, has very low PM25 concentration, and it's very normal. And you can do a lot of things here. You can do a lot of, you can change gradient to see it properly, change radius or change opacity, etc. You can do whole lot of things with this heat map. After moving from this analytics or plotting of data, because we already have now PM25 concentration data, now what we want to look is, we want to first look for a correlation between traffic and tweets. So basically we want to see whether tweets can be used as a model for traffic or not. And for that what we did is we plotted the sketch data of 2014. These red dots are actually showing the sketch data, so number of cars passed through this sensor. So these are basically sensors at different positions, these red points, and these are the tweets which are made from the road. So what we can do is we can actually draw a polygon and select a particular, only a just section of, very small section of road. So like this, you can actually, very small section of road you can select using this polygon. You see polygon, or you can draw a circle to just know what is happening around this thing. Or what you can do is you can select one or more than one street or road. For example, uh, right now I'm going to just select this street which is near uh, I think Brook Street. So I'm just going to select this and the next street through a box. Now what is happening is whenever we are selecting a particular section of the road, street, or a full road, or section, or a pair of street or road, what we are doing is what's happening at the background is this. So it's generating a graph for weekly basis, for like Monday, Tuesday, Wednesday. What's the relation between amount of traffic and number of tweets? Again, then if you select a particular day from here in the graph, for example, I just select Thursday. So Thursday was this. So I'll just get hourly access to it, to that data also. The point behind that was we just wanted to see what's happening at busy hours, so 6 to 9 you see, and then again increase in traffic. So we just actually wanted to see at different time what's happening on different days. So basically what we observed was, as the during office hours or busy times in the morning and evening, as the amount of traffic increases, uh, number of tweets also increases. So that was the correlation we have seen. So this is again for Wednesday. Now moving from after setting the correlation between a number of tweets and amount of traffic, what we want to see is there any relation between amount of PM25 concentration in a region and number of tweets. So basically at the end we can say that as the number of uh, because we have already stabilized in busy hours, as the number of tweets increases, amount of traffic increases. If we can find a correlation between amount of PM25 concentration and number of tweets, we can easily say that on the basis of number of tweets, as the tweets increases, PM25 concentration must be, as in a region, if number of tweets are more or increased, PM25 concentration in traffic, PM25 concentration must have also increased. So for that again we plotted amount number of tweets on the road and also PM25 concentration in different region. So again we can actually draw a circle to find what's happening in a location, or we can actually select a, we can again select a polygon or draw a shape. Just if you want to, if you just want to, yeah, if you just wanted to select a particular section of road like this, or you can again select multiple roads, yes, like this. So Flinders Lane and part of Flinders Lane, Russell Street, Flinders Street, we have just selected this part. Now again it will generate a graph based on that. So first it will generate a weekly graph. So right now it's generated for the circle one, so it will change. So this is what I'm saying. Even so, is this a small part in both the correlation, we are just like selecting a very small part, still it's taking uh, comparatively more time as compared to big data technology. So yeah, this is our graph for Monday, Tuesday, Wednesday. Now if we select a particular day, I'm just going to select Tuesday, so we can see what's happening on Tuesday on hourly basis. That gives us more insight into our data, so that we can actually know what's happening at every hour. To find a correlation, it's actually very much important. So it's still processing. Yes, so we can see total population exposure versus selected region and of select for the select region and number of tweets. So you can see in the morning and here. So as the amount of so as a whole, if you see in this interval and in this interval, in the morning office hour, as the traffic increases, PM25 concentration is also increasing, and also when people are leaving for home, traffic increased and number of tweets increased for this region, Flinders streets and all, because it's an office area. It's actually has to be happen. So this is Colin Street, so Flinders Lane. So this is actually very important area. So after setting correlation between number of tweets and traffic model and amount of number of tweets and PM25 concentration, we can say that in busy hour we can actually model both of them based on number of tweets. So it's actually very important to do that, because the data, pollution data and traffic data from EPA and Vic roads respectively are not available. So it's a very good initiative to model it based on number of tweets, in order to find these in order to find all these pattern very easily. Now moving to finding a correlation between number of pedestrian and PM25 concentration. For this we used pedestrian data from City of Melbourne. So basically City of Melbourne provide pedestrian count for CBD areas. So hence you can select any location in CBD. So you will see a drop down, and yeah, all these street you can select any street in CBD which has these sensor which are recording all this number of pedestrian data. And then for a particular day, so right now I've selected state library and Monday out of all those days, and you can see the correlation between PM25 average pedestrian count and PM concentration. So this is average hourly pedestrian count over the past 52 weeks, and this is PM25 concentration. We consider 52 weeks so that we can have enough data to find a correlation. So we can actually see correlation in the morning 8 to 10, and again when people are leaving home, and in between also where people go for lunch. So this is actually good uh, good correlation we have found. And state of library is actually near to some of the university like RMIT and University of Melbourne. So yeah, so in lunchtime we should have more uh, more number of PM25 concentration as PM pedestrian count is increases. Now pedestrian count increase also shows that amount, these are the busiest hours, so the number of cars on the roads are also increased. That's why we are also seeing PM25 concentration. So we actually, if we know pedestrian count, we can also relate it to PM25 concentration. But here the main thing what we wanted to see is whether increase in PM25 concentration is affecting sentiment of people. Are they getting depressed, or are they tweeting more negative tweets? And we actually find a strong correlation. So again we plotted number of pedestrian count versus sentiment analysis. So yes, you can again see in, so in this time period when the traffic increases, in this time period number of negative tweets were more as average. So here also negative tweets are more, and here from positive to neutral in morning. So people are actually going from here positive to negative, which shows that they are getting depressed in office hours. So basically we have related both of these through number of pedestrian, because we actually knew pedestrian uh, data for a particular, very specifically for a particular region, so here this you can see. So this was a very good correlation. So we were actually able to set correlation between PM25 and sentiment through pedestrian, that as PM25 concentration is increases, sentiment analysis or number of negative tweets for the people are also decrease, are also negative, which shows depression. However, some other reason can be traffic or noise pollution in those area, which can lead to more negative twos. But yeah, air pollution is one of the is also one of the factor which causes depression among people during busy hours. And so basically I'll just show you the from where we took the pedestrian data. Here, from here we took the pedestrian data. This is the pedestrian counting system by City of Melbourne. These are the different sensors around, and here you can select the date, time range, and you can download the data to see a particular location. So yeah, so for example, this is City of Greater Street and Swanston Street. In our report we consider this, and we took 52 weeks average. Now moving to our next correlation, that is correlating between number of deaths in a region, which are related, number of deaths, or the deaths which are related to air, or which can be caused through air pollution, versus amount of trucks in that particular region. So basically we want to find out if number of trucks increases, air pollution increases, right? So if number of trucks increases, whether number of people dying from a disease which can be caused by air pollution are increasing or not. So for that we have actually plotted different data for different SLA region, and all these that is red section are SLA 11 region, and yellow boundaries are kind of separating between different SLA region. And for every SLA region, so when I click a SLA region, for every SLE region we need number of deaths from lung cancer, ischemic heart disease, respiratory system diseases, and COPD diseases. How many people died from this? Average yearly deaths we are talking about. So this we took this data from Orin, and this is the area name. And we if you click a particular road inside this SLA region, yeah. So this is the Macclesfield Road inside this area code or SLA region. It has 350 trucks in it. So we have plotted all this data to find correlation between them. And after this, setting up this, what we wanted to do is for whole Australia we wanted to know whether there is a correlation or not. And for that we use uh, uh, spatiotemporal queries to find for particular in every area how many roads are there, and then we summed up all these trucks in that particular region, and then we kind of summed all the deaths in that particular region, and then we found relation between total deaths and total trucks. So this was the correlation we found. So for example, for this, okay, yeah, so for this region Brimback, as the total number of trucks increases, there is a spike for number of deaths also. So you can see everywhere where the spikes goes on, there is a spike for number of deaths also. Here also in Vietnam Sea North also. So basically it's showing strong correlation between both of them, uh, between both of these things. And in our report we have also shown r square values, r square, that is finding we did regression between both of these to see how perfectly one can predict other, and it our adjusted r square comes to 60%, which is actually very good. Thank you guys. And now before leaving I just also wanted to show, as we shown on live HTML, we shown sorry, for different region we see pollution exposure for different street, but we can also see pollution. So here also in heat map we see pollution exposure as a whole, but actually what you can do is you can also see pollution exposure for a particular person too. So here if you select a particular person, like if I select Arsenal, you can see this weekly pollution exposure for all his whole data. So on Thursday he had the maximum pollution exposure, and then for a particular day, for example Thursday, you can also see hourly exposure, how much he is exposed to PM25 concentration. So here you can see in the morning, in the evening. This thing can actually helps a lot for a particular person to know if he is having some health problem. It may be due to his consumption of air pollution, and he can also change his path what he is following right now based on this. Thank you guys. At last this was our whole analytics, and as you can see there was a lot of lag in doing all these analytics. This is because of the reason that we are using traditional system. It's very slow, and hence we wanted to move to big data technologies. So this our report shows how big data technology is 10 times faster than all these to do all these analytics or other computational tasks, because of using in our architecture we are using big data technologies like Spark, Hadoop, which are very fast, or Accumulo, which is very fast than all these traditional system based on MySQL. Thank you guys. Thank you.